If your scripts still lean on MS Online or Azure AD, they're already legacy. And if you think that doesn't apply to you, oh boy, you're exactly who I'm talking to. The cloud moved on. Your modules didn't. Modules break on Linux runners, containers, CI/CD. REST doesn't. PowerShell isn't going away. The modules are. We're going API first. I'll show you the raw REST pattern, 3 auth flows, and 3 enterprise demos that actually ship. There's one gotcha that ruins most graph scripts. We'll fix it later. If you're still loading modules in 2025, you're heating the office with old Exchange servers. Why PowerShell without modules is the future. Everything you care about lives in Microsoft Graph now. Users, groups, devices, Intune, Teams, SharePoint licenses, app registrations. The portal writes Graph. Your scripts should too. REST beats modules because it cuts out the middle mess. No load times, no dependency roulette, no version drama. You call the endpoint, you get the data, you move on with your day. Token speed credentials, full stop. OAuth 2 with certs or managed identity gives you short-lived access, clean audit trails, and automation that doesn't depend on a human remembering a password they already wrote on a sticky note. Managed identity means no secrets at all. That's the point. Less to steal, less to rotate, less to screw up. Cloud native means it runs everywhere. Azure Automation, Functions, GitHub Actions, containers, Linux, local. PowerShell core is cross-platform, but Graph is the constant. Curl works on anything with a pulse. Invoke-RestMethod does the job without dragging in the structural integrity of wet cardboard. Remember when installing a module meant praying to the NuGet gods? Those days are over. Benchmarks aren't glamorous, but they're loud. Load time. Modules lag. REST is fire and go. Cold start in a function or an actions runner. REST starts immediately. Modules sit there thinking. Reliability. Modules choke on throttling or stale tokens you never asked for. REST is predictable if you set headers and handle retries. Portability. Linux and containers don't care about your module drama. REST just runs. Here's the business side because someone will ask about value. Faster delivery because you don't wait on module updates. Fewer outages because you control the token and the retry logic. Easier governance because permissions are explicit and scoped per job, not hidden inside someone's global profile. Cost, your cold starts stop wasting minutes. Your failures go down. No works on my laptop nonsense. The thing most people miss, Graph updates instantly. Modules lag by weeks or never. New feature, it lands on Graph first. You can call it today. Oh, waiting for a module means waiting for a maintainer who isn't on your payroll. Meanwhile, your project deadline didn't move. And yes, modules load slower than my ancient Exchange server. Graph doesn't care, it just responds. So you can pin versions on V1, test beta endpoints when needed, and guard it with feature flags. You get to control change instead of being surprised by it. Security teams will actually like this. Least privilege scopes per app registration. Admin consent reviewed on a schedule. Cert-based auth with short lifetimes. Managed identity where you can. Certs where you must. Every call leaves a trail. Request IDs, correlation IDs, who consented to what. You don't get that from a plain text password stuffed into a script like a loose wire in a breaker panel. So why now? Because the cross-platform reality is here. You're running on Linux runners, building containers, pushing jobs into functions. The module stack was built for a Windows-first world and a simpler set of products. We don't live there anymore. All right? Enough theory. Here's the pattern you'll use everywhere. Get a token, set headers, call REST, handle paging, honor retry after, and move on. It's boring, which is why it works. The core pattern. Native PowerShell plus REST plus Graph API. Here's the pattern I promised. Token, headers, REST call. That's the loop. You'll reuse it for everything from listing users to smacking non-compliant devices. Scripts don't fail because of PowerShell. They fail because of assumptions. So stop assuming magic. Build the 3 pieces every time and you'll sleep at night. Start with the token. You've got 3 ways to get one and they map to real life. Device code for local testing when it's just you at a console. Client credentials with a certificate for automation where no one's clicking anything. Managed identity when you're in Azure and you want secrets to disappear like they should have years ago. Same outcome, different doors. Device code is the friendly one. You request a token for HTTPS, Graph, Microsoft.com. With the scopes you need, you get a code, you open a browser, you confirm it's you, and PowerShell gets a token back. Great for building the first version and poking endpoints. Bad for production because humans are squishy and forgetful. Client credentials is the adult path. You create an app registration, you grant it only the Graph application permissions it needs, and you add a certificate. Your script signs a JWT with that cert, and request a token using the PowerShell default scope for Graph. No user, no prompts. Clean audit trail, rotate the cert and move on. If I see a client secret pasted in plain text again, I'm revoking Wi-Fi. Managed identity is the quiet killer. You enable it on your automation account, function app or VM. Then you call the local identity endpoint, ask for a Graph token, and Azure hands you one tied to that identity. No vault lookups in your script. No secrets to rotate. You just need to grant that identity the Graph app roles it requires. Least privilege means fewer 2 a.m. calls. Now the headers. Don't overthink it. Authorization, bearer your token. Content type, application, JSON for anything with a body. When you're doing advanced queries or searches, add consistency. Level, eventual, and the appropriate prefer headers if the endpoint supports them. The thing most people miss is they forget the consistency level and then wonder why their count or filter looks drunk. Then make the call. Invoke-RestMethod is fine. Method, URI, headers, maybe a body. The mental model is simple. Token, headers, call, check, page, retry, continue. You'll page through results using @OData. Next link whenever it shows up. If you only got 100 items, that's not a mystery. That's the default page size. Follow next link until it stops. Put a guard on your loop so it can't run forever if the API burps. Now here's where most people mess up. You must respect throttling. Graph doesn't care about your feelings, implement retries, or enjoy failures. If you see 429 or 503, look for retry after. Sleep for that duration plus a little jitter so you don't join a thundering herd, then try again. Exponential backoff beats panic clicking. If your automation can't survive transient errors, it's not automation, it's a suggestion. Common mistakes, so you don't repeat them. 1. Wrong audience. You asked Entra for a token to management. Azure.com and then called graph. Microsoft.com. That's a 401, not a conspiracy. 2. Pagination denial. Why 100 rows only? Because you never read next link. 3. Tight loops without delay. You angered the throttle gods and now everything's slower. 4. Over-permissioned app with directory. Read write all just to test. You just failed an audit you haven't had yet. Let me show you the quick wins you can do today. Device code, grab a token, get me, and confirm you can read your own profile. That proves your token and headers are wired. Client credentials, use default, call users, select ID, display name, mail to keep payload small and process a page or two. Managed identity. In Azure, call Intune's device endpoint via graph, set top, follow next link, and dump only ID device name and last check in date time. Good versus bad scripts, because contrast helps. Bad, module error, import, fail, update, fail, coffee, fail. Good, rest error, token, call, done. Sure, you'll wrap it in functions and add logging, but the backbone is boring on purpose. One more pro move, build a tiny retry helper and a pagination helper once. Pass in the URI and headers, get back the full dataset with retries already handled. Suddenly every script is 20 lines shorter and 10 times calmer. The game changer nobody talks about is you can test these helpers locally, then drop them in a container or a function without changing a line. Done. Enterprise Demo 1. Intune device cleanup. Tenants rot. Devices stack up like abandoned carts in a grocery lot. Policies get noisy, compliance drifts, and suddenly your reports look haunted. Let's clean it with graph, no modules, on a schedule, with logs you can show to security without blushing. Here's the plan. We query Intune devices from graph where last check and date time is older than a threshold you set. We decide action by age and tags. Disable if stale, retire if older, delete if fossilized. And we check ownership first so you don't nuke personal devices because someone missed a field. Boring, predictable, safe. Start with the endpoint. You're calling get https://graph. Microsoft.com/beta device management, manage devices with select to trim payload. ID, device name, operating system, last check in date time, managed device owner type, Azure AD device ID, and any tag you rely on. Use filter for server-side cut. Last check in date time, LT 2024 101 teaser. If you can't filter exactly how you want, pull with the conservative window and filter in PowerShell. You'll get paging. Follow @odata.next link until it stops. Guard the loop so it can't spin forever. Then classification. Corporate owned, evaluate action thresholds. For example, 30 to 60 days, mark for review, 60 to 120, retire, 120 plus, delete. Personal owned, maybe you only notify or tag for review. The thing most people miss is time skew and inactive but just reprovisioned devices. Cross-check Azure AD device ID against Entra device last seen if you need more confidence. If there's conflict, skip and log. Now actions. Retire is opposed to managed devices, ID, retire. Delete is delete managed devices like ID. Disable often means flipping state where supported or writing a tag and letting policy handle it. Batch where the endpoint supports it but don't stampede. Respect for 29503. Honor, retry after with jitter. Write every action to log analytics, device ID, action, reason, timestamp, result, request ID. Correlate with a run ID so you can reconstruct the story later. Horror time. I watched someone delete 800 devices because they didn't understand last check-in timestamps. They filtered on a property that lagged for re-enrolled devices and skipped dry run. Graph did exactly what they asked. It always does. Intune never lies, but boy does it stay quiet until it's too late. Don't be that headline. Automation setup. Use an automation account with a system-assigned managed identity. Granted least privilege. Graph roles for device read and the specific device actions. Store non-secret config in variables, thresholds, tag names, action map. Have a feature flag for dry run. Dry run writes what it would do, not what it did. Run that first, then run it again, then maybe touch production. Mistakes to avoid. Nuking devices during a regional time skew. Forgetting to limit by platform when your Mac fleet reports differently. Running with directory. Read-write. All just to test. No back-off policy and hitting global throttles so the next team's job also fails. Write logs, not feelings. Punchline. If the portal shows it, Graph can do it faster, quieter, and on schedule. No module drama, just tokens, headers, calls. Enterprise Demo 2, identity onboarding via Graph only, 450 words. Onboarding should be boring. If it's exciting, something is wrong. We're wiring HR to identity with Graph, so accounts show up licensed, grouped, and ready before the manager gets impatient and opens a ticket. Flow is simple. Client credentials with a certificate, not a secret. Your app registration has only the Graph app roles it needs. User, read-write. All if you must create users group. Read-write all if you must assign membership, directory, read all for lookups and the license assignment roles. Admin consented once, reviewed quarterly. Your script signs the request, asks Graph for a token using Pascal's default for https://graph.microsoft.com and starts the pipeline. Step 1. Create the user. Post to users with minimal attributes. Account enabled, true, display name, mail nickname, user principal name, usage location, and a temporary password with force change password next sign. In true, if you're not using SSPR start, keep it lean. If the user already exists, you patch, not freak out. Idempotency means you can rerun safely after a failure, and it won't make a mess. Step 2. Assign a baseline license. You'll get subscribed SKUs once, cache the SKU map, and pick the right SKU ID. Then post to users-ID, assign license with add licenses containing the SKU ID, and disable plans array if you do selective services. Handle quota gracefully. If you're out of licenses, you log a blocking event and notify the right channel, not explode the run and leave half-created objects. Step 3. Groups by role. You keep a configuration map from job code or department to static group IDs. Names drift, IDs don't. You put or post to groups/group id, a member's ref with the user's directory object ID. If the user is already a member, skip. If the group doesn't exist, that's a configuration failure, not a runtime adventure. Your script keeps moving for other memberships and logs the miss with correlation ID. Step 4. App access. Many enterprise apps hang off group assignments or app roles. For app roles, you post to a service principals/SPID app role assigned to with the user's object ID and the app role ID. For group-based SSO, adding the user to the right group is enough. Again, use IDs from config. No name lookups in hotpaths. Guardrails. Correlation ID per onboarding. Every graph call logs request id, URI, method, status, duration, retries. Retry, back off on 429.5xx. Feature flag for dry run, which creates a plan but does no writes. Idempotency everywhere. If user exists, patch. If license exists, skip. If group membership exists, skip. And for the last time, if I see a client secret hard-coded again, I'm revoking Wi-Fi. Use a cert or manage identity. Quick win, this runs on a Linux runner with PowerShell core. No modular load, no waiting for someone to publish a fix. User shows up in seconds with baseline access and your help desk doesn't touch a thing. Now your pipeline is the quiet, boring part of onboarding, the way it should be. Enterprise Demo 3, compliance drift detection and remediation. Compliance sprawl is the slow leak that flattens your week. Devices drift, users get risky, tickets pile up like snow. We're going to scan, target, remediate, and verify, all with Graph, no modules, and without waking up SecOps at 2 a.m., start with a schedule and a managed identity. This job isn't special, it just needs to be reliable. The identity gets only the Graph roles it needs. Device compliance read, device actions if you remediate, identity protection read for user risk, and the session revoke permission. Don't grab directory. Read-write. All just to test. That's how audits become folklore. First pass, devices. Call get https://graph.microsoft.com/v1, device management, device compliance policy, settings 8, summaries or the device compliance states, endpoint your tenant uses. Use select to keep payload small. ID, device name, user principal name, operating system, compliance state. Filter where you can, compliance state EQ, non-compliant. You'll get pages, follow add.data.next link, put a guard on the loop. Now classify. Non-compliant doesn't mean execute order 66. You map severity to action. For low severity as maybe a push notification or an email with a remediation guide. Medium, trigger a remediation script or force a policy sync. High, quarantine the device or block access to sensitive apps. Batch, where the endpoint supports it, but keep the degree of parallelism low. Throttling friendly, not stampede. When you act, log like an adult. For every device you touch, write run ID, device ID, action, reason, request ID, status, and latency to log analytics. If a device flips to compliant during the run, skip and note the flip. After remediation, recheck status. If it's still non-compliant, escalate once, not 5 times. Alert thresholds, not spam. Users next. Pull risky users from identity protection via get https://graph microsoft.com v1. Identity protection, risky users. Filter, risk level EQ high, and selected user principal name, risk level, risk state. For each high-risk user, take targeted action. Revoke sign-in sessions via post to users to ID, revoke sign-in sessions. If your policy demands it, temporarily block sign-in. Patch users ID with account enabled, false, time-boxed, and logged. Mini rant, don't carpet bomb sign-ins. Use severity. You're not diffusing a movie bomb. Reality check. Compliance isn't a state. It's a drifting target you have to chase. That's why we use Delta where possible. For device compliance, if Delta endpoints exist for your scenario, use them to avoid rescanning the world. For users, keep a cache of last processed risk change timestamp. Query only what changed since. That's how you keep runs under budget and under the throttle radar. Common mistakes. Blanket blocks without a severity filter. Congratulations, you just created a help desk fire drill. No audit log. Now security wants names, times, and reasons you can't show. Hard-coded IDs. Someone renames a policy and your script face plants. Put IDs in config, not code. If you can't reproduce a run from logs, you're guessing. Punchline. Detect, target, remediate, verify, log. Quiet, repeatable, and boring on purpose. Architecture breakdown. Identity, automation, execution, observability. You've seen the pattern. Now wire the plumbing so it doesn't fall over when someone sneezes near Azure. Identity layer first. Managed identity wherever the workload lives. Automation account, function app, container in ACI, VM. Flip it on. Grant only the graph app roles the job needs. And stop thinking about secrets. If you can't use managed identity, fine. Entra app registration with a certificate. Short lifetime, stored in key vault, rotated on a schedule. No secrets in scripts. Not in dev, not just testing, not ever. Automation layer. Use Azure Automation for simple schedules with runbooks that wake up, do one job and go back to sleep. Use functions for event-driven flows. User created, device status changed, license inventory dipped. Small, fast, cold start friendly when you're not dragging modules. GitHub Actions for CI, CD, and cross-OS runners. Stick the same scripts in pipelines that validate, then deploy to prod. Local PowerShell for validation and reproducible tests before you throw anything at production. Execution layer, PowerShell Core plus Invoke-RestMethod. Version pin your endpoints, v1. For stable, beta only behind feature flags with clear blast radius. Build 2 helpers once, a retry handler that honors 429's 503 with exponential back-off and jitter, and a pager that follows @OData. Next link with guards, drop those helpers into every script. Suddenly your code is small, predictable, and not stitched together with 3 connectors and a prayer. Configuration and secrets. Store non-secret config like group IDs, SQ maps, thresholds in JSON or environment variables. Keep 1 config per environment so you don't hardcode anything that will drift. Secrets and certs live in Key Vault. Your code reads via managed identity, not a magic string in a PS1 file. Feature flags for dry run and confirm impact make rollout safe instead of theatrical. Observability. If you can't see your automation, you can't trust your automation. Send logs to log analytics, request ID, correlation ID, URI, method, status, duration, retry count. Trace the whole flow with a run ID so you can reconstruct what happened without calling 6 people. App insights for dependencies and live telemetry on functions. Azure monitor alerts on patterns that matter, failure rate spikes, throttle rate surges, SLA breaches, not every 404. Guardrails. Least privilege map to jobs, not teams. Pin versions. Review app consents quarterly. Dry run by default in new environments. And yes, Microsoft wants you here. Not because it's cute, because modules can't keep up. This stack is faster to ship, simpler to govern, and it doesn't panic when you move it from your laptop to Linux to a container. That's the point why Microsoft wants you on Graph. Microsoft wants you on Graph because it's the one surface they can actually ship to at speed. Identity, devices, apps, content, the portal writes Graph, so your code should too. Features hit Graph first. Modules get love when someone finds the time. Sure, so is winning the lottery. Governance gets cleaner. OAuth scopes and consent tell you exactly who can do what, and every call leaves a trail you can audit without rummaging through someone's profile script. Scale? The endpoints handle global traffic if you handle paging and back off like an adult. Cross-platform reality, Microsoft ships PowerShell core, but Graph is the constant. The thing most people miss is maintainers don't control product release speed. REST schema changes land, your code can adopt them that day. Beta has risk, pin versions, and wrap with feature flags. Permissions will sprawl if you're lazy. Design roles per job. The portal is just a pretty face on top of Graph. Don't be the last person to realize it. Best practices: security, reliability, speed. Security first. Use managed identity wherever it exists. When it doesn't, cert auth beats secrets. Short lifetimes, rotate on schedule, store in key vault. Least privilege graph roles per job, not per team. Quarterly consent reviews or enjoy surprise outages. Reliability next. Handle pagination on every list endpoint. Detect 429, 543, honor retry after. Add exponential backoff with jitter. Idempotency everywhere. Check before change, upsert patterns, use e-tags when available. Delta queries cut scan time and cost. Performance matters. Use select to trim payloads. Batch where supported. Parallel with limits so you don't stampede the API. Cache static lookups like group IDs and SKU maps with a TTL. Observability isn't optional. Log request ID, correlation ID, URI, method, status, duration, retry count. Keep a run it for multi-step flows. Track success rate, P95 latency, throttle rate, and delta efficiency. If your automation can't survive a 429, it's not automation, it's a suggestion. Write logs, not feelings. Code hygiene keeps you sane. Small functions over 500-line scripts. Config driven via JSON or environment variables, no hard-coded IDs. Feature flags for dry run and safe rollout. And yes, test your backoff. Graph doesn't care about your feelings. The gotcha that ruins most graph scripts. Alright, the promised gotcha. This one ruins more graph scripts than anything else, and it's not even interesting. Wrong token audience. You ask for a token to management. Azure.com, then you call graph. Microsoft.com, and you stand there wondering why you got a 401 like it's a plot twist. It's not, it's you. Fix is dull and absolute. Audience must match resource. If you're using client credentials, you request for HTTPS graph, Microsoft.com with the default scope. Device code? Same story. Scopes for graph, not something you copied from an Azure ARM tutorial in 2018. Managed identity? Ask the local endpoint for graph, not whatever's in the sample. If you mess up your token audience, don't worry. You'll know immediately. Graph will reject you faster than a bad Tinder opener. Bonus trap, pagination plus filtering. Not every property is filterable server-side. If the docs say it isn't, believe them. Do what you can with filter on supported fields, then finish the cut in PowerShell. And when you mix search, count, or advanced queries, remember the consistency level eventual header, or you'll get results that feel like they were assembled by a drunk spider. Sanity checklist before you hit run. Token audience is graph. Required scopes granted and admin consented, pagination handled with guards, retry with backoff wired and tested, logging on every call with request ID and correlation ID. Scope it right or enjoy 401s and a long walk through Entra logs. You've been warned. The future is pure graph. Here's the takeaway. The future of PowerShell is tokens, REST, and graph, not modules. Move one thing to graph this week. Start with your worst module script. Ship the token headers call pattern. Use retries. Kill secrets. Then come back for the advanced patterns and my throttle safe retry function. Next episode has the reusable auth wrappers. Stop living like it's 2016. Graph is the job now. Modules are nostalgic. Graph gets the job done.